Good morning, everyone. Good afternoon, everyone. I hope everyone is following along us, and thank you for joining on a Saturday morning or evening. I appreciate you taking time to be here and learn something and give us more energy and more support for this particular program. So, welcome everyone. And today I have with me Prasad and Abhijit would be joining soon. Yeah, but there are we have like three people today to help you out and keep your questions coming. We would be happy to answer as many questions as we can. So, let me add Prasad. Prasad, are you on camera?
I can come on camera. Hello,
Yeah,
everyone.
hello. Good. Thank you. So we will go through single agenda. I already pushed the agenda on LinkedIn. Some of you are here for first time probably. So I will just give you an idea that we run this program every Saturday, 9 a.m. GMT to 11 a.m. GMT, 2 hours, and we talk about technical things. We talk about networking stuff, and then we will be talking about some of the hands-on activities also. So hopefully you would enjoy and you will learn something. And if there is any feedback, feel free to let us know. Any agenda items you want to add, anything you want help with, reach out to us on LinkedIn and we would be happy to help you in all the ways we can. So, hopefully, you would enjoy and you would be learning something new today. So I will start with some basic stuff and then Prasad would take over and we'll talk about the hands-on. So today we will talk about three things. Technical track, I'll talk about Amazon S3 here, storage in cloud. Then we will talk about networking track. We'll see how networking works into cloud. And at the end, Prasad would help us with the hands-on how to utilize S3 and deploy some solution or have some hands-on experience using Amazon S3. All right. So
One
enjoy
question
your
before
day.
we
Go
start
ahead, sir. Yes, sir.
is like, has everyone now created AWS account? Last
Yeah,
time there
that's a
were
good question.
last time there were few people who did not have AWS account. Now as we are getting into it, and we will be doing some hands-on. Everyone has AWS accounts.
Yeah,
That's awesome. Great.
that would be nice. Yeah, that would give you lots of good experience. And when you do things, you retain that knowledge. You just like learn something, but you actually can say, hey, I've done it. And it will give you more confidence in your interviews or in any preparation of certification or whatever. So that's a good thing. And a lot of
Cool.
people are saying yes. And be
Yeah.
mindful of the cost, right, Prasad?
Exactly. That's what I was about. The next question was, have you set up your billing alerts? Have
Yes,
you
yeah,
secured
that is
your root
important.
account?
Yeah,
Right?
yeah,
So ensure that you do those basic steps before you start playing on. Because see, from this week, as Ashish will start covering more and more technical stuff about the AWS core services, right? Like we'll start with storage, then we'll go to compute and database. We will talk about the hands-on activities. Like in 30 minutes, we'll showcase few things, but then there will be a lot of workshops that you can do in your own time to learn, and then there might be a cost associated with it. So ensure that
exactly.
you have the billing alerts set up and you are using the free tier appropriately, not leaving the resources, a provisioned, like deprovision once you complete your lab, clean up your AWS accounts so that you don't incur any charges.
Exactly. Nice tip. Now, Divyam had a question. Can you please update the resources of week one? I did it last night. I hope I have did the commit in GitHub. So can you please check? It should be there. Week one resources should be there. I have put them into like batch three in the resource section and week one. So the content should be there. Let me know if you find any errors there. I did it very late night yesterday, so little dizzy that time. But yeah, hopefully everything would be there. Now we have Abhijit also. Hey Abhijit, good morning. I'll add you to stream.
Morning, everyone. Morning, good
How you?
afternoon.
Good afternoon. How are you doing?
Yeah, not bad. It's
Oh, good,
Saturday
good,
morning,
nice.
and I especially like that background music before actual streaming started. That's like a good kick for the morning to start.
Yeah, means and it's a good audio checker also, right? Isn't it? Like otherwise people say, "Hey, I'm not listening," and
Yeah,
somebody's speaking, but at least when you hear music, you know that you are well connected. Good.
absolutely.
All right, thank you. So thanks for sharing that link here. GitHub link is there, so please get that. And I'll quickly start now without wasting much of the time. I'll be then going off camera and helping you to understand and focus more on the content related to AWS, Amazon S3. And I'll talk about the basics first, as I do always, and then we will go into the detail of implementation. So let's first talk about some of the basic stuff related to storage into the cloud. Now, storage is an integral part, right? In last trainings, we have discussed about the global infrastructure. We talked about region, availability zone, edge location, and how all these physical components help you to build your solution. And once you have sorted this thing out, when you know which region you are going to use, afterward, you would start looking for platform-based services. Now, foundational services, I would say, these foundational services are compute, networking, and storage. Now, it depends on how people want to view it. Sometimes people would add database also in foundation, but I say database lives on top of compute, networking, and storage. So I would consider it as a platform service, but you could also call it as a foundational service. But for any application you run, you would need three components. Compute, anytime a code is running, you would need to process that code, right? It is Java, .NET, PHP, whatever, or you are just authenticating through login. You are verifying a user is valid or not. For that, you would need some processing power. So that is provided by compute. Networking, obviously, you would need to have connectivity to other system or maybe connectivity so users can access your application. So that would come on networking. And then you have to keep your data and store your data for long term or maybe short term, whatever the requirement is, that will be called your storage. So these are three basic foundation services. Whatever you build in some shape or form, you would use compute, networking, and storage. And we will start focusing on these two things. And once your foundation services has been sorted, what you can do, you could leverage some higher level services, sometimes referred as platform services. Like you can have deployment management, you can run analytics on top of it, you can run product catalog. So lots of things can happen once you have done all these things. Right now I am focusing on storage, and then we will focus on the networking part also as part of networking track. All right. Now, storage in AWS Cloud. Now, storage can be of different types. So I will first give you the basic examples of storage, and then we will go for the implementation detail. When you are a solution architect, knowing the why is more important. Sometimes when we are learning technology, we are just focused on like what this technology is, or how to implement this particular solution, or when to implement this solution. That's all. But here the importance for a solution architect would be that why I am actually implementing that, what business problem I am trying to solve. So that would be a very, very important aspect of whatever you do into any type of environment. So always think why this technology, why we have to go ahead with this type of architecture, why not other architecture. So why is very important if you are looking for a solution architect to be in making. So let's go ahead and talk about storage. So there are three type of common storages you will find into AWS. Sorry, not in AWS, but all the places, right? You have three common storage type. One is called block storage, second is called file storage, and third is called object storage. They have specific use cases. Think of it like you have cars. Now, there would be a family car, there would be a racing car, there would be a high end, your luxurious car. So it depends what your use case is and what problem you are trying to solve, and that's why you would get that. Right. So let's focus on what is block, what is file, and object storage, and I'll give you example of each of that so that you could relate these things in your real life. Now, as an analogy, consider that you have a piece of land. Right? Hopefully, you acquired that piece of land, and now you could decide that, hey, I am going to divide this piece of land. I would be creating a garden in this place. Maybe on this section, I would be building a house, and in this section, I would be keeping a open area. I won't be doing it anything here, and maybe here I would be creating a storage. So what you did, you basically bought a piece of land and then you divided it, you partition it into your own requirement, and in that partition you could do different thing. Like garden would be looking different, your house would require solid floor, so you would have that. In garden you would not have a solid floor, but you would have a muddy floor. And then maybe in your storage you would have a different type of flooring, maybe to protect it from flooding or something. So that what we are doing here, we are trying to have a storage and then divide it for our own usage depending on what we are planning to achieve from this. That is called your block storage. So block storage is where I would have given a block of storage and then I decided what is going to be my usage of it. Think as a piece of land. You could decide here to build garden, open space, parking, depending on your business requirement, right? Now, How it relates to your computing world? Consider you got an hard disk like in your laptop or in your desktop. Now, most of the laptop only have just one partition. If I'm talking about Windows, it would be C drive, most of this, right? But if you want, you could go ahead and say, hey, I would be creating one more partition. I would be using this as a C drive and I would be using as another D drive. And maybe I would keep my backups here or I would keep my logs here. And on C drive, I would just keep my operating system. So that can be one option for you. You could have the same disk divided logically to keep separation. And if you are little more techy, what you could have also done, you could have said, instead of creating a D drive here, I would create a partition. Here I would run Windows based operating system, and here I would be running Linux or any other operating system. So this is a dual boot, same disk but logically partitioned to accommodate multiple operating system inside. That is completely possible. So that is your block storage, where you have flexibility to create partition and format those partition as per your use cases, right? All your laptop hard disk, all your server hard disk, or when you are creating an Amazon EC2 instance, they are all having a block storage associated with that. If you're coming from on-prem world, if you have heard about SAN storages, so when you are creating a SAN, and in that we create something called a LUN, logical unit number. SAN stand for storage area network. This is purely a on-prem environment world technology. You would be presenting this LUN to a server, and then the server can format it, partition it the way it wants. So that's what is a block storage, right? Keep your questions coming. If there are any technical questions you are not clear, I'm monitoring the chat and I would be happy to answer those questions as they come. Consider file storage. I take an example here of an apartment. So in an apartment, what you could do, you could have a place given to you. So let's say this is a whole building, and in that this is a floor, and on that floor there is apartment number one, apartment number two, and apartment number three. So these type of apartment are there. Now I can't go ahead and say, okay, I would be breaking a wall here and will create a door here. That is not possible. You can't do that. That is not technically allowed to happen into this apartment. What you could do within your apartment boundary, you could go ahead and say, I would be changing the carpet, or I would be having a different color on the wall, or I would be changing the location of closet here and storage here, and I may be having a different type of a stove into my kitchen. That is all possible. But you cannot make changes which would be affecting others, like creating a door here, or maybe saying I would be blocking the door here. Those type of things can't happen because you are sharing the space. Same thing applies on file storage. What happens in case of file storage? Somebody would set up a file server for you, and they would be giving you permission to access this file server. They may give you different type of permission, and it is expected that a file server would be accessed by multiple people. So some of them may have a read write access, some may have only read access, and some of you may have full access on top of it. But you can't say that, if even if I have a full access, I can't say I would go ahead and delete the whole file server or format the file server. I am allowed to perform only file label operation, nothing beyond it. So that is my file storage. We'll think like an apartment, right? Hope everyone is following along. The third one here is a object storage. This is relatively new to some people. Think of the storage units. So in this storage unit, let's say if you are traveling from, or you are shifting from one place to another, and you are looking for a place to keep some of the stuff, you could rent the storage units like this. And in this storage unit, either they would charge you for the number of boxes you keep inside, or they would be charging you based on the whole unit you are consuming, or how many number of units you consume. But these are not designed for humans to live. These are designed only to be kept with stuff. You could keep on adding stuff. You would have your own lock and key, and when you need it, you would have access to it, and you should have no problem in keeping as much physically possible inside the storage unit. And you would be paying probably charges based on the unit you consume, or maybe based on number of boxes you consume or store into these places. So hopefully this thing is clear, that what is a object type of storage, what is a storage unit. I'll paint a picture of technical stuff in a minute, so you would have a better understanding on that, right? So storage type, In block storage, the unit of transaction is block. What I mean by that, behind the scene, there would be some disk. Let me call it HDD, hard disk drive. This hard disk drive is controlled by an operating system running on top of it. On top of that operating system, you would have your application running. Let's say you are running MS Word as an application. Now, Word doesn't know how to create a block or how to store a file. But it can, when you create a new file in MS Word, it would just inform operating system and say, hey, I have a new file and I want to store it. What operating system would be doing, it will find out that where is the space on hard disk, and in those blocks of hard disk my file would be stored. File may be split across multiple blocks and then it would be stored. It may not be one single block which I am consuming for my file. So that is not my application's responsibility. It just talks to operating system, and operating system figures out what blocks to be allocated. So my file or data is stored into blocks. It is created by operating system, right? So unit of transaction is block. When I'm talking about file storage, my transaction unit is file. We will create file, update file, modify file. That will all happen through file storage. That's what we would be doing. And when we are talking about object storage, we store objects here. Now, object confuses a lot of people. It is a fancy word for files which has metadata information, some additional information which we have put, that will be called my metadata information. Let's say you have a box to ship to someone. On that box, you could put a sticker and say this has to go to the buy, or this is going to be on a urgent basis delivery or a fast delivery. Maybe you could put inside that this is a fragile item inside. Maybe you could put that this one has some XYZ type of stuff inside. So additional information which you have added to the box, that is your metadata. So metadata would ensure that you can identify various aspects of the object. You can run some additional queries on top of it based on metadata. So additional information which is we are adding is referred as a file metadata, right? Now, examples here. If you are using a laptop disk or a server disk where you see boot partition or data drive, this is your block object. File storage, when you are connecting to a server in a format slash slash server slash share name, that is your file storage. And if you have ever used OneDrive, Google Drive, or Dropbox, they are all referred as your object storage. That doesn't understand the details of the object. You store a file or a photo or a video, it doesn't matter. It would just be adding that as an object. So those are all my object storages, right? How you update, this is important. Now, in block storage, you can directly update the file. Means your application would say, I want to update something, and then that will be request going to operating system, and operating system would update the file for you. Same happens in file storage. When I'm saying file storage is again basically a server behind the scene who has some operating system running which can accept the connection, and it has lot of storage associated. So whatever request you say, I want to create a file, it is accepted by operating system here, and it will go ahead and add capacity or modify whatever you require. Shouldn't be a problem. Some of the file format used for data engineering in this object storage, it could be anything, Samuel. We do not have any specific format to use, right? So maybe you have generated your CV, which is in doc format, or you have a document which is PDF, or you have a MP4 file, or you have a CSV file. It doesn't matter. You could store as much as you want in object storage, and it doesn't care about file format. For the object storage, it is just a sequence of ones and zeros, nothing else. So it just thinks that there is some data written into 10 format, nothing else. That is what we mean by an object, right? So is file storage same as NFS? Answer is yes. File storage is an concept, and to perform access to this file, you would be using some protocol. NFS is the protocol we use, but name of the protocol and the storage unit is so interchangeably used that we just call it NFS share. But NFS technically is a protocol used to access the file server, which is hosting the file system you want. Samba server, yes, exactly. Samba is also one of the product which is a file server, and you could have connect to it using NFS protocol. And some more protocol which I'll talk about is CIFS, Common Internet File System. This is more fine-tuned towards Windows-based user. NFS is fine-tuned towards Linux-based user, but they both are protocol by which we can access it. How this is different from EFS, we will talk about that. We'll discuss that. Like we have block storage used for booting purpose, can object storage used for similar purpose, or it is just a storing purpose? Prashant, no, you can't boot from object storage. Think about my example. The storage unit. Can you live with your family in a storage unit? Answer is no, it is not designed for it. It may not have hot water, cooling, the electricity supply. So it is not designed for it. It is designed to only keep, it is like your garage. You can't live into garage long time. So it is not designed for booting. Object storage cannot be used for boot. For booting, you would need always a block storage. Your operating system would need a block level access. Okay, good. Now, so how you can update things? In case of both type of storage, which is file and your block, you can update directly, should not be a problem. But when it comes to object, you cannot update object directly. The example I give here, let me go back to the screen here so that you would have a better idea. See this. So let's say this is a box here, if you can see here in the corner. If I have to update something in that, maybe I want to get something out or add something inside the box. There is no space within the unit. So what I have to do, I have to get the box out, modify the content of it whatever I want, and then push box back in. That's how I would modify. So we cannot add object, we cannot modify object in object storage. There is no edit command, there is no modify command available. What you do, you just create a new version of the object and keep both the version old and new, or you just overwrite the object, but there is no edit command in object storage. Now, some software would give you impression like you are editing it, but actually you are just replacing it. Let's say you have a file in Google Drive and you opened it and modified something, so you feel that I am going to utilize a file storage, but it is not. Temporarily that file is open into some program and then changes are stored there, right? So how about AWS FSx? We are coming to that. Just hold on to that question, we will talk about that. So hopefully this thing is clear, that how can you update? You cannot update the object directly. You create a new version of the object and replace the existing one, or keep multiple version of the same object. So you can keep multiple object, shouldn't be a problem at all. So yes, you can do that. Right now, this is the thing which we were discussing, like talking about the protocols associated. Sorry. So protocols which we could use is SCSI, Fiber channel, serial ATA, WinBlock, SMB, CIFS, NFS. These are the protocol used to access file storage. And when it is object storage, you mostly access object using HTTP or HTTPS, and then you utilize REST and SOAP kind of a thing on that. Right. So that is what we do with the object storages model. Right. Additional, sorry, I'm not sure my mouse is not working as expected. Give me a minute. Yeah. So support for metadata. With block and file storage, we do not have metadata support. The tags which I told you, additional information which I want to keep, that is not there with my with my block and file. But with object storage, we have support metadata. We can add extra information, like on that shipping box, you can add different label like a barcode, like address, to, from, priority shipping or not. So that is what we mean by a custom metadata which we can add on it. Now, this is theoretical concept, how AWS implement these things. So probably you will get some answers here. If you are using services in Amazon, which is Amazon EBS or Amazon Instant Store, that is a form of a block storage given to you. If you have used EFS, Amazon EFS service, Amazon FSx service, they are example of a file storage service. So EFS is fine-tuned, as I said, is for Linux-based operating system, and FSx is fine-tuned for Windows-based operating system. So depending on your use case, you could utilize these all type of things, right? So that's how these things are. Now, object storage is having two options here, which is your Amazon S3 and Amazon Glacier. You could utilize those two things, should not be a problem. So this is the example of block, file, and object storage. Now, a good question from Junior Barth. Why is block storage faster than other type? Let me try to draw that so that you would have a better understanding on that. Right. So let's say this is my disk. Let me use a different color. If it is my block storage, my operating system directly has access to the disk. So my application, whoever is running here, would just talk to this operating system and I would be able to communicate on that. The protocol which is used for communication here is called SCSI protocol. Small computer system interface. You can read more on that. And SCSI is designed for this type of data operation like reading block, writing block, and all. So this happens in your block storage because your operating system is sending SCSI command to the disk. Now this disk could be a local disk on the server itself, or it could be a remote disk like a SAN storage associated. So that is block. So command is SCSI, which is directly going to the operating system or from operating system to the disk. When I'm talking about network, so let's say this is my file system. Now file system is mostly over network, right? So in front there will be a server and that server would have some storage associated and you would be accessing this over the network, right? Now network, what we are using behind the scene we are using TCP IP protocol, and on top of the TCP IP protocol, then we use NFS or we use CIFS. So what is happening now? I am making a long distance call first thing, and I am using a protocol which is not designed for heavy data transfer. It is basically designed for request and response and smaller size of packet size, whereas the SCSI, the block size is much higher. In TCP IP, the packet size is much smaller, and that's why this this file storage would be slower for you rather than a block. Same happens in object. So when you are accessing a object storage, your requests are going to that object storage over HTTP or HTTPS. These protocols are not designed for huge data transfer, whereas SCSI is designed for huge data transfer, and that's why block is always faster than any of them. Because here what happens, your packet is created, then that packet will go through encapsulation, another layer, and then it is sent. So that will be adding a lot of burden, and then packaging and repackaging and then encapsulation, decapsulation. That's why block is always faster because of the protocol used behind the scene, right? So I hope that would be a better idea giving you that how all these things work. If your questions get answered, let us know in the chat that you are able to get the answer, and if you have any follow-up question, put that there too. Sam says, as EBS is a network attached volume, how does it achieve fast processing while updating an existing file? As I understand, it only replaces the change block. So there is some protocols behind the scene. Now, what happens that behind the scene, if I go ahead, there is a network which is called SAN, storage area network. Most of the time, it is designed using fiber optic cables, most of the time. And this is able to carry huge volume of data, and then it will see whenever you are using a block storage, that is your, let's say, hard disk remotely, though it is blocked, but there is still some operating system running here who would take care of operation, or the software which is running in your storage array. So that storage array software would be getting information that okay, file has been updated, which blocks has to be changed, and it will just send that information. So though it looks that it is happening over network, first thing, it is happening over fiber optic network most of the time. And wherever your storage exists, that storage would have its own management software, or you can think of like a small operating system fine-tuned to run these operations. So that's how it runs, right? Okay, let's move forward. So hopefully the storage types are clear. Now my focus here is on a storage which is called Amazon S3. Amazon S3 is the name is simple storage service, a service which exists from 2006 onwards and still growing. There is always lots of new features being added in that. So that is called my simple storage service. Here, the concept is bucket. So to get started with Amazon S3, what you have to do first, you have to create something called a bucket. Bucket is same like a folder which you create, similar, right? It's just an example. So like you create folder in your traditional operating system, you will create a folder, and that is referred as a bucket here into AWS world. And in like in folder you keep files, in bucket you would be keeping something called objects. So object is what I want to store, and I would be accessing it over HTTP method, and I would perform some operation on that. So what I'll do, I'll quickly go to console and walk you through the small process of creating a bucket, and then we will see some additional stuff around it. So I'm here, and now I am utilizing AWS console. Probably everyone knows about it, and Prasad would talk about more interesting stuff to do with Amazon S3 and hands-on, but I'm quickly showing you how to create a bucket and then how to update objects inside it. Whatever I'm doing here from the graphical interface, the same can be done from command line. The same thing can be achieved using your API or SDK call also, should not be a problem. So as soon as I come to S3, you would see here that it shows global. S3 namespace or the bucket name which you create is a global, but when you create a bucket, that bucket is a regional entity. So let me say create a bucket. If I'm trying to create a bucket with the name test, and I'm selecting US S2 as a region, and I go ahead and say let me create a bucket, I won't be allowed because this bucket name may have already existed. So let me go ahead and create a bucket called BESA and 18 Feb 2023 just to make it unique. And I could have selected any of the regions. As you see, these are all the regions where I could have hosted my bucket. Let's say I say I would be hosting it into EU Ireland. I won't change any default ownership as of now. Block public access is also there. I'll keep it, and I just go ahead and say create a bucket. So bucket is a placeholder which will get a unique name assigned as we have seen, and I could search for that bucket here. This is my bucket which has been created. Now, does it bucket having any object? Answer is no. So there is nothing inside. What I could do, I could go ahead and upload some objects inside. Should not be a problem. So I could go ahead and say, hey, I want to add some files. Give me a minute. And let's say I go ahead and put like a summary card of AWS. That is a file I selected, 169 KB. So it detected that it is a PDF file. It is smart enough. And this will be going into this namespace like you have a HTTP address. This is a S3 address with the name of the bucket. That is my destination. And if I want to change some properties like storage classes, or maybe enable encryption, or maybe add additional checksum information, or add tags like we were talking about, we could do that. But I am keeping it simple, and I just created a upload of object into Amazon S3. Right. What Amazon S3 did now, it has created a unique URL for this particular object. Whatever I am storing will be given a unique URL to identify that object and to access that object. Objects are private by default. Unless I make them public, nobody can access it. Only I as a owner I am allowed to access it, but this is my object URL. Let's read what is into this object URL. I'll put it into a notepad so that you could easily see this into a little bigger font. So what we see here, HTTPS, endpoint is HTTPS. We are trying to talk to a bucket BESA 18 Feb 2023 in a service called S3 in EU West 1, which is Ireland region, Amazon AWS.com, and this here is my object name. Object name in S3 is called as key, right? So my object here is a summary card.aws.pdf, right? What bucket can give you, we can go ahead and add folders here in the bucket itself if I need to. So I have created this bucket, and if I feel now I have to add more folders inside, no problem. See this option, I could say create a folder and call it, let's say it is my PDF files. I could go ahead and create a folder, and done, folder is created. Now for you and me, it is looking like a folder, but behind the scene, it is just a namespace. And if I go into this PDF folder now and I upload a file inside it again, Let's go ahead and add additional file inside. Let's say I go ahead and add this summary card cloud computing inside. That is the object I am uploading, and I just clicked on upload. This will again get a unique URL. We will see that what the URL is in a minute. My object is there, and then we would be successfully uploaded it. And let me close that. So this is my object. Now its URL would be little different. We'll be having a PDF as a folder name here. See this. Now, for the first object, my key was summary card aws.pdf. So this was the first object key. My second object key is this whole stuff. So for you and me, it would look like that, hey, we have a folder structure, but S3 just says, I have an object whose name is summary card aws.pdf, and I have another object whose name is pdf slash summary card cloud computing.pdf. So for you and me, it may give a impression that there is a folder structure, but for S3 behind the scene, we are trying to create a flat structure, and this whole name or what we call prefix is allowing you to have a folder like structure, but behind the scene it is a flat way of storing your data, right? So hopefully this thing is clear. Shri on Cloud says that is S3 created in a particular region? Yes, answer is S3 service is global. So the namespace you create for a bucket should be globally unique. But whenever you create a bucket, that bucket exists within one region only. So when you create a bucket, you have to select which region, and only then a bucket would be created. Why we do that? Because you may have some legal requirement that I am storing data of, let's say, credit card information, and that is for a specific country people. So I can't keep that data away to all other location. If I'm, let's say, working in EU, my compliance requirement may say that this data has to be kept in European Union. So I have to create a bucket, and that bucket would never copy data outside of the region unless you specify so. Right. So behind the scene, what happens as soon as I'm uploading an object? Let's say this is the object I uploaded. In most cases, what would happen? You would have, or I would say in every case, you would have three copies of that object happening automatically. We want to give you durability that if you have a specific use case of keeping an object, so you uploaded a file, let's say a.txt, behind the scene, S3 would create three copy of that a.txt file. Idea is even if one of them fails, we are able to recover from the failed copies if something goes wrong. So that is what a file would be or object would be copied to. Minimum three copies of an object would be maintained, right? And possibility is if you have used something like a S3 standard tier, in S3 standard tier, probably these copies would be created into different availability zone. So one copy into AZA, another into AZB, and another into AZC. So even if one of the availability zone goes down, you won't have a problem in accessing that data. And that excess of data which you can anytime get it, that is durability and availability. Right. So I'll talk about that in a minute. So bucket is regional entity. Whatever you store has to go into a region. S3 makes copy by default. Answer is yes. It will automatically make copy. You won't be seeing that, but automatically to maintain the durability we promise, which is 11.9, yes, copies are maintained. So here the bucket is the storage box. Object is using folder created in the content into as per example from our object storage. Yes. So S3 is a object storage. In that you create bucket, and in that bucket you would be further creating object. This is how the structure is. You can't have a bucket inside a bucket. You would always be having S3 namespace, and you would start adding your bucket, and then you would keep on adding object inside. Object may have a name like a.txt, or it may have a name like folder slash a.txt. It doesn't matter. This is for you as a human to understand. For S3, it is one object with the name folder a.txt and another object with the name a.txt. Right. Okay. Are S3 object encrypted by default when we upload to bucket, or do we need to enable encryption? That's a good point. Now there is a change recently, very recently, few days back only. What we have now, that any new bucket you create, new, they would have encryption enabled by default, not the previous one, right? So for previous, encryption was optional, but for newer bucket, encryption is mandatorily automatically enforced for you. So that should not be having a problem. Now every new bucket you create is automatically storing your data into an encrypted format. Good. So what happens here, that we could have bucket which is regional, we can have durability 11.9, and then availability. Plus availability is 99 per x percent. Durability, I would say durability is basically meaning the retention of the object. So if I have some outage, will my data will be still retained? I would be saying yes, because we give you 11.9 of durability retention. Availability is the access of the object. Can I access that object right now or not? But they are two different things. I use a very basic example to explain durability and availability because people feel confused on that. Let's say this is office building you work on, and this building operate from 6 a.m. to 12 to 11 p.m. let's say. So only this time you can physically enter into this building, right? You forgot your laptop here. You went to a party in the evening, you got late, and now you can't enter into the building because the building has closed. That doesn't mean that my laptop got stolen. Laptop is still there. When in the morning I would have access to the building, I would still be able to get my laptop back. So my laptop is retained into the building, but I can't access it now. My access is limited right now because I am beyond the time when the building opens up. Right. This one is your availability. Is my data available right now? Is my laptop available right now? Answer is no, because I am beyond the time. But is my data or laptop retained? Answer is yes. This one is called your durability, right? So S3 stores your data, let's say, into a region. Let's say this is region 1, and in that region, your data is stored across 3 availability zone, right? Your data is stored here. Now, if there is a network outage, what may happen, that you may not be able to connect to the region, right? So I am not able to access my data right now, but my data is still there. Once the network problem is solved, I would be able to get my data again, and that is called my availability of the data. So these two sound similar, but they are different, durability and availability. And the maximum object size you could have for S3 is 5 terabyte. So you would be keeping at least 5 terabyte of that data. Maximum size can be 5 terabyte. S3 storage files in 3 places. I assume the storage will grow exponentially. How storage is managed by AWS? Surya, it is secret sauce. Means it probably AWS won't tell you that how they manage it. And think from a customer perspective. I'm not interested in, let's say I go to McDonald's and I order something. I am interested in that, hey, I want my burger. Now, where the bun come for it, how they source the ingredient, who made it in for my kitchen, I don't care. The SLA is once I place an order, in 15 minutes, my product should be with me. And that's all I'm worried about. As a customer, you should not be thinking about what actually is happening behind the scene, and that will be all done by service provider. And probably, even if you know that, it won't help you because we are governing a SLA that we say we will design our storage for this type of durability. So that is all. Then you are just following that, and then you can, if we cannot fulfill that SLA, then we would have some penalty, and we would be able to like pay you in some credit or do some other things. So that is a SLA. So what happens behind the scene, like I ordered something from online, how and who shipped it to me, I don't care. I want a service, and that is coming to me, and that's what is cloud about. You have a SLA, and the service provider would fulfill that SLA for you. Doesn't matter how they do it, right? So S3 can be used for lots of things, can host a static website also for you. Compute, you could get compute on that. Like you pay for compute, number of requests which is coming to S3, you will pay for that. Storage, you will be paying for capacity you are using to keep your data. And if the data transfer happens, you will be paying charges for that. So most AWS services, you pay for compute, for storage, and for networking. And the same applies to Amazon S3 also, right? So I hope this is clear. Now S3 is a topic I could talk for hours and hours on that, but we have limited time. So I hope this is a good starting point for you. There are more features in S3 like versioning and replication and transfer acceleration. So I would be putting the slide deck and I would be giving you some more example here like this. So this will be in the slide deck which we will publish. Some more detail about another storage called Glacier. Then we have Snow family also. And now, if you want to learn more, I have recently published a free training on Udemy. So this training is available and it talks about all these S3 concepts which we could not cover because of the time limitation. So check this training. I'll put this link into the chat here and just bookmark it. You should be able to get this training for free in cloud in Udemy. Just go through that and all this 2 hour training will walk you through the various aspects of this thing. We could not use it. Last question I'm taking here from Abhi. If we want to store 50 terabyte of data, what can we do? Break it, right? So if you have like a whole ship to send something or whole house to send somewhere, you can't send the whole house. What you would be doing, you would be breaking it into smaller pieces. So if your one single file is 50 terabyte, I would say it is little wrong to be created. But if you have still done that, what you would be doing, you would be utilizing the approach or you would be utilizing the breaking of it, and there are ways to break it. So if you have bigger object than 5 TB, then you have to break it and put it into smaller piece. Using multi-part upload for larger file, yes, you can do that. Why not? That is also a possibility that you could go ahead and do multi-part upload in that case. So I hope everyone has followed along. And if you like this training, put rating, put some comments there so I would know and let me know what else you would like to see. So if I get time, I would publish more trainings like this to help you understand. Right. All right. Is maximum limit of 5 GB per object? No, 5 terabyte. 5 terabyte is the limit for every object. Also, in this, in the slides which I would be sharing, we would have this single story or single summary page. So you would get all the details about that service. So if you are in rush, you want to understand the basics, go ahead and read this service summary slide. I would also include the service summary slide for your Amazon S3 Glacier. So you would have a better understanding on that. Right. So let's go ahead and take a short 5 minute break, not 10 minute. 10 would not work for us. So let me go ahead and put a 5 minute timer and then we will talk about the next topic, which will be networking track, right? So enjoy your 5 minute break and I'll talk to you in few minutes. Thank you.